My name is Arthur Hicken, and I'm one of your hosts today. And with me is Wilhelm Hawker. We both work at Parasoft. We're going to cover a whole bunch of interesting stuff. We know that coding standards can be a really confusing, crazy area. So we're hoping to give you some clarity today. Now, one thing that I like to start with, because we're talking about coding standards, and standards have kind of lost their meaning. And so I want to talk about what they're for so that we can understand which one will work well for us. And when I talk about cybersecurity, I'm really talking about the software security in and of itself. And the basic idea is that we have to build good software. We can't just take crummy software, weak software, and try and turn it into the most stable, secure software ever. So it's very important to get the software right in the first place. And that's what the coding standards are about. And static analysis is really your best way to enforce a coding standard. Now, there's different kinds of analysis that'll help you enforce these coding standards. There's runtime error detection. People have IAST now. There's flow analysis. There's code smells. There's preventative standards. And they all are actually related to each other. So if you think about having maybe an uninitialized memory error in your application, which could be a security weakness, a runtime analysis tool will find this problem if your test suite is extremely thorough. And it's always how thorough is your test suite. Now, flow analysis may or may not find this uninitialized memory. It depends on the complexity, where it's in the application, how deep it is, etc. But it might find it. Now, it turns out that there's a preventative static analysis rule that would make it not so that it would find the uninitialized memory, would prevent it from happening in the first place. And that would be something like initialize variables on declaration, like int I equals 0, then it can never be uninitialized. So some standards are designed to detect problems, and some are designed to prevent problems. So that's the basic part of it. Now, the way this works, I think about something like the Tower of Pisa, right? We all know the Tower of Pisa is not straight, it's crooked, and it gets more and more crooked every year. Trying to straighten the Tower of Pisa is really, really difficult. Now, what a lot of people don't realize is that in the United States, we had the same problem here. We have this big, tall, white tower, this Egyptian-looking obelisk in the middle of Washington, D.C., and it's very, very straight. It's been there for a long time, and it's not crooked. And what happened is, as they were building this, they found out that the bedrock wasn't solid. And so if they built there, it was going to end up being like the Tower of Pisa. So it's pretty interesting because this monument is supposed to be in the exact center between the Lincoln Memorial, the Congress, the Jefferson Memorial, and the White House. And as you can see from the little red tick here, it's a bit off center, and that was their prevention. Rather than put in a tower that's going to lean, they said, you know what, let's move it over, let's build it on solid ground, on a good foundation, as it were. Now, it turns out there is a method to try and straighten this tower, but it's really insane, and you don't want to have to do this with your software to get this crazy. So a simple example now, again, about something like Heartbleed, right? Heartbleed swept through everywhere a couple of years ago, right? It was a weakness in OpenSSL, and we've all come to rely on OpenSSL for our encryption. And when Heartbleed was first discovered or published, there weren't any static analysis detection rules that would find it because it hadn't been discovered yet. But it turns out there was a bunch of different coding standards that if they had been followed, it would not have happened in the first place. So I've listed a few here from MISRA and CWE, but basically any large coding standard will have things that would make sure that you're doing proper validation, that you're not doing out of bounds reading, that you're handling the parameter length and things like that. And those were really the underlying problems. So if whoever built OpenSSL, who worked on that code, had been following these engineering standards, these secure coding standards, it wouldn't have happened in the first place. And that's the real strength. So let's look at a bunch of these standards. As you can see, there are a ton of them. And today we're going to focus specifically on the ones that have a direct correlation to code. So things like DISA and NIST aren't coding standards. MISRA and AUTOSAR are, for the most part, functional safety standards. They don't have security except for a little addendum, so we're not going to cover those today. GDPR is a privacy thing, but it doesn't have a specific coding standard, so we won't cover that today either. But we're going to try and cover the big ones: CERT, CWE, OWASP, etc. And of course, you can see from this mess, right? Like standards come along, and then someone goes, "Wow, that's a mess. There's too many standards, so let me create one more." And I kind of feel like that's where we are today. We'll cover UL 2900 briefly, and you'll see that it's, I like UL 2900, but in some sense, it's one of these. Although they did something really, really smart that we'll see. So let's jump in with the first one, CWE. This is probably one of the most well-known, at least in the United States. It's the Common Weakness Enumeration. So in the US, we have a thing called CVE. When there's a security problem, like in your router, in your firewall, in your Microsoft OS, et cetera, you find this alert comes from the government or from the manufacturer, and there's this funny CVE-201-90623, blah, blah, blah. Each CVE, which is the vulnerability enumeration, gives every vulnerability an ID, and then they look at the vulnerability and figure out what were the coding problems that allowed this to happen, and those are CWEs. So CWEs are really like symptom focused on code that is related to vulnerabilities or hacks or exploits. Now CWE is big, there's over 800 items in it. It can take a lot to get into. So they've done something interesting, which is they made a top 25 list. And the top 25, as you can see in the chart on the right, are the things that are most likely to happen and cause the biggest problem. So they're not just like, this is the most dangerous academically, but in reality, these are the things most likely to affect you. Every now and then they revisit it. The current one is from 2011, so they haven't changed it in a while. Unfortunately, like those first two, like command injection and SQL injection, those should have gone away by now, but they're still the biggest problems. There's another little list. If you've heard of the top 25, there's a secondary list called the CUSP. And what they are is 16 more. So it's like the CWE top 41. And basically, I think of them as the honorable mention. They didn't quite make the list. They were on the cusp of making the list. So it's a really bad pun. The other interesting thing about CWE is there's this risk scoring system, and it's all about technical impact, basically helping me understand what kind of things can happen to me. And the reason this is important is that it's hard to know with 800 items or even 25 items or 41 items. You get so many potential violations in your code that, what do I focus on first? Which one are most important? I need to still get product out the door. I don't have time or money to produce perfect software. I have to produce software that's as safe as I can reasonably make it. So severity is a step that people use, but this common weakness risk analysis framework, CWRAF, in combination with a common weakness scoring system, or CWSS, helps me understand the technical impact, meaning if somebody exploits this kind of code construct, what will happen? If I take something like a buffer overflow, what happens? Well, it might lead to a denial of service. Or maybe if I have an injection, that might lead to unauthorized access to data, or an escalation of privileges, or the ability to modify data. And so they've broken all these items out so that now, instead of looking at some crazy, arbitrary, weird description of code like read overflow, you now know, oh, this has a technical impact that is a denial of service, and I worry about availability, so I will worry about that. So it's really cool. And in fact, there is an ISO standard for this. It's not a coding standard, but it's called 2710. And you can see all these nifty little buckets here that talk about what are the impact of software quality problems. Now, the blue buckets are the ones that are currently correlated with CWE. So if you think about doing static analysis, quality and security together, and safety even, like you see in automotive and aircraft, these things can all correlate to this ISO 27010. So I think it's kind of cool, this very concept, not of what's the code or what's the symptom, but why do I care? So I think it's pretty nifty. So let's talk about OWASP. OWASP is the Open Web Application Security Project. The open part means that, yeah, it's free and it's community, right? So you can contribute, you can learn, you don't have to pay money, really cool. They have a top 10 list again. The top 10 list is not meant to be your full end answer to software security. It's meant to be a starting point. So if you haven't done anything, this is a really great way to get started because they've said, like CWE, here's the things most likely to happen. We'll dive into that in a moment. It's a language independent standard, so it doesn't outline specific things for C versus Java versus .NET, for example. There are 10 items in the list, but there's really about 50 sub-items when you drill into it, like injection. Is it SQL injection? Is it command injection? Is it LDAP injection, et cetera? The answer is it's all of them, right? So not every item on the list is statically analyzable. For example, A9, using components with known vulnerabilities, also known as software component transparency, also known as software composition analysis. Basically, it says, hey, if you're using open source components, make sure you've checked them for known vulnerabilities like CVEs that we discussed a moment ago. And you can look in places like the National Vulnerability Database, or NVD. So that's one of the things there that you can't actually do with static analysis, but OWASP provides a tool for that, so kind of cool. One interesting thing too is that the OWASP standard, rather than being re-implemented, is really used by UL 2900 standard. So if you're doing this, you're on your way to complying with another standard, which is cool. And the FDA is given kind of, as much as they will, a seal of approval. They never tell you exactly what standards to use, but they have accepted and announced that if you're using UL 2900 with OWASP, then you're doing the right thing. Again, there's a risk scoring system. It's kind of cool. It's based on these 4 categories. How exploitable is the item? How prevalent is it? Because they're looking for the ones that are the most common. How detectable is it? In other words, if I have this weakness in my site, is it easy to find or is it really hard to find, right? And then what's the impact? Now, their impact here isn't categorical like CWE, it's severity. So will the impact be nasty to me or mild? Obviously, things that are easy to exploit and easy to detect and have a severe impact are the things that you want to work on first. And so it's important when you're working to make sure that your tools implement that. This is just a quick summary. You can see that each item on the OWASP top 10 has an inherent impact and score to it. And so you see why number 1 is number 1 on the right. It has the score of 8, which is an aggregate of these various categories. So we're going to show that when we get into the demo. It's pretty cool. So let's talk about CERT, right? CERT is from the Software Engineering Institute. It's the Computer Emergency Readiness Team. They have the secure coding standards there. They're language specific. They were made with a lot of community involvement. There's a wiki there. You can go, you can sign up, you can ask questions on a particular item in the standard. You can ask for examples, ask for clarification, contribute to it, discuss things that you think the standard should include, or categories or various branches of them. So it's a really cool thing to get involved with. It's really focused a lot on engineering and prevention. It's a very useful standard, not just for software security, but safety as well and reliability. So there's a lot of proactive things in it. For example, instead of, hey, look for tainted data or look for injection, there are standards in it that say, make sure you write the code like this so that you can't have a buffer overflow. Make sure you write the code like this so that data won't get tainted. Make sure you use validation rather than look for validation problems. So it's a very proactive approach, very good if you're trying to shift left. Rather than early detection, it's really better construction, as I started with when we started the webinar. Lots of rules. I call them rules. They're really 2 categories. They have one category, they're called rules. They're very strict. The ones that are called rules means that they're pretty nasty and it's actually easy to make sure that you can detect them from a rule. So they're a pretty good choice. The ones that are in the recommendation category instead of rules, well, they're less strict. And basically, they're either lower impact, meaning this isn't so dangerous, it's just something you want to think about or maybe look at. You don't necessarily need to follow it, but it's interesting advice. Or there might be things here that are just difficult to analyze, and so we really can't require it. So if you're starting with CERT, frequently it's a good idea to implement the rules first. When you come into terms with that and get into compliance, then you start adding the recommendations to improve your standards. Again, there's a very practical risk scoring system that I want to show you that you should be looking for if you're implementing CERT. Your tool should do this. So here, the CERT people have done it a little differently than OWASP or CWE. They have these three categories, which is what's the severity, meaning how serious are the consequences, and again, likelihood. If I don't do this, how likely is it that it will lead to an exploitable vulnerability, right? So not just a theoretical one, but do I believe that someone from the outside of the system, a bad actor, can take advantage of this? And then cost, and here the cost is mitigating. So mitigating might be putting up a firewall, it might be rewriting the code, it might be a new release, it might be adding authentication, encryption, et cetera. So what's the cost of that? And so each of these has a value from 1 to 3. And obviously, if you get a bunch of highs and your value is nasty, then it can be really, really bad for you. And the cool thing is you multiply all these together and you get a number. 3 times 3 times 3 would be a 27, and that would be as nasty as it gets. So basically, the center of the bullseye is your most nasty stuff. The yellow stuff is, hey, I've got a little time, I want to do better. The green stuff is all really low severity, unlikely to happen, expensive to repair. If you've got all the time in the world, feel free to look at that. In reality, none of you ever are. We actually implemented this thing. It's kind of cool. It's kind of fun to use when you're working, so we'll show that to you. Let's talk about PCI-DSS. This is the Payment Card Industry Data Security Standard. Now, this isn't a general purpose software security standard, but it's got some really good hints and guidelines in here. In fact, we're not going to talk today about HIPAA or GDPR, but I would say if you were trying to do those, just do PCI. It's a good start, right? Like, it won't cover every item for those, but it'll get you a good start, because PCI is all about trying to protect credit card data. So it's really a good place to go. It's a big framework. There's a lot of interesting items into it. You can see from the chart here. Basically, if you're handling credit cards, this applies to you, right? So you might be a small retailer, but you're taking credit cards online yourself and you're storing credit card data, then it applies to you. You might be a bank, it applies to you. You might be a clearinghouse, it applies to you. So it applies to a lot of people. If we look at this, there's a bunch of different sections, 1 through 12, and section 6 is really the one about developing secure applications. So it's really the dev part, if we were thinking DevSecOps rather than the ops part. One other thing I want to mention before we go a little deeper in this is that the current version is 3.2.1. Version 4 is coming pretty soon. You can get information on it. So I expect some minor changes to come, but I don't expect from a coding standard perspective it to really change all that much. So if I look at that requirement 6, develop and maintain secure systems and applications, we have to have a process that identifies vulnerabilities. Well, that might be that you're doing pen test. It might be you're doing static analysis. Smart would be doing both. You need to protect from known vulnerabilities. In other words, make sure that you're patching your software, that you're updating your open source libraries, et cetera. You need to develop software securely. Boy, that's kind of that's a tough one. How do you even define that you're doing that properly? That's a little tricky. Make sure you have change control processes and procedures so that, for example, I want to make sure that test is different than production so that I'm not accidentally using real credit card data in my tests. One of those kinds of things. 6.5 is the actual coding standards, and they break down to, look at the list, it looks very similar to our OWASP top 10 or CWE top 25. Injection, overflow, insecure storage, insecure communications, improper error handling, all of those normal kinds of things that are in there. Now, because an audit can occur with PCI, it's very important that when you have static analysis checkers, that you're able to demonstrate to an auditor that, yes, I implemented static analysis to prevent buffer overflow and look for buffer overflow, and it was this checker, that checker, the other checker, and here's when they were run, and here's the results of running it. So I promised I would mention UL 2900. This is a newer standard, an emerging standard. You're probably familiar with UL because they're Underwriters Laboratory, and every electronic thing you own probably has a little circle with a UL on it, basically meaning that it's not going to shock you or start on fire or anything else. So they have a new standard called 2900, which is cybersecurity for network connectable products. There's some variants of the standard, 2900-1, -2, et cetera. There's a medical variant, there's a nuclear variant. So basically, there's a core standard that tells you, here's all the things you should do. And then inside the medical one, it might be more or less strict depending on the context that you're working on. And the really cool thing here, so we started with the funny cartoon, right? Like there's 14 standards, let's make a 15th one. So UL has a new framework here, but instead of create a new set of static analysis rules that look just like every other set, they've basically said the static analysis rules you need to do are the CWE top 25, the CWE CUSP, remember we talked about that, you probably never heard of it before today, but there you go, and the OWASP top 10. So you're going to do all of those. So if you do this one, you're covered against CWE and OWASP and UL 2900. So it's a pretty good footing to have. Again, like PCI, the way that UL works is that you have to demonstrate compliance. You can't just say, hey, I do some OWASP top 10 stuff. I don't know what that means, right? And so as we show you the demo, we're going to show you how you can prove that you're doing things and survive an audit. So I wanted to show you just a basic workflow, right? You have an architect working, you have developers, you've got source control system, you've got some kind of, is it build, continuous integration? And basically, architect's job is to figure out what is the right test configuration. So here it might be that I'm going to do OWASP. And so I select the configuration and make sure that everybody on the team gets it and that that same configuration is available to CI and build. And actually, the system we're going to show you, this doesn't imply that I'm going to go to every single desktop for every developer and every server in the CI system and install a configuration. It's all handled through a central location. So that as an architect, if I choose to update it, everybody instantly is in compliance with what I'm doing. And then we expect sort of a, a trust but verify mentality, the old Russian proverb. The idea being that the sooner a developer gets the information, the quicker and easier it is for them to understand, what is this? I just wrote this code, I understand it. It's not weeks or months later. And so I get the advice, I can fix it. But we expect that in your CI, you have a larger context. You have the whole application. So you might find something you wouldn't find otherwise. Plus, you just want to validate that the people really did what they were supposed to do. So that's my trust but verify. And out of that, we have our DTP platform, which helps you get reports that you need for managers and leads, helps you do manual triage if you want, helps you understand what's our risk, where are we at. We have all these risk scoring systems implemented there, and then really cool reports ready to go with the click of a button for an auditor showing what was my plan, how am I going to implement it, what deviations did I have, all just done automatically for you. We can actually send these results right back. We can update the configuration based on seeing what's happening. We can push these results into the developers' desktops as well so that they can actually, if the CI found something that their desktop didn't find, they can consume that result as well. It's pretty cool. So your basic process here is pick the standard that's relevant for you. For example, if you're doing web application, OWASP is a good start. If you're going to be doing a medical device, then UL 2900 might be a more obvious choice for you. Make sure that as much of the standard as possible is covered with static analysis so that you're doing a lot less manual work. Tune the configuration as necessary for you. So you might have some old code that you really can't go to a strict standard on. You might have particular files that have a certain context that they're okay, so you have some deviations, things like that. Make sure that you tweak the thing so that the results you're getting matter to you. And then wherever possible, when you see, for example, that SQL injections occurring or tainted data is occurring, start looking at the preventative checkers to make sure you can eliminate these problems. And then my final piece here, start as small as necessary, right? If the OWASP top 10 is still too big to bite off, implement number one. Like in order, because we saw that the risk is higher with the lower number. Implement number one, and if that was easy, implement number 2 and 3. Maybe the next time you add 4, 5, and 6 to your next iteration. If it's too much to swallow, don't expect that you can do it. Don't try to boil the ocean here. Just pick off one thing and be more secure today than you were yesterday. So with that, I'm going to turn it over to Wilhelm, and we're going to look at this stuff.
Awesome. Thanks, Arthur.
So the first thing I'm going to show you is that architect's perspective, right? As a security architect, I want to go and how do I choose the standard from Parasoft? So here we're looking at DTP, and I'm going to come in and in this particular case, the example I'm going to be working with is .NET code, so we'll be looking in here. Parasoft also supports Java and C and C++ as its core languages. And it's a web application I'm working on, so I'm going to take Arthur's suggestion here and look at the OWASP top 10 rules. And one of the first things I want to point out about this interface here is take a look at the categories and the name of the checkers. And notice that this is really a mapless standard, meaning that it's very obvious just by looking at the name of the checker how it corresponds to the standard that we're looking for. There's no mapping, there's no Parasoft specific ID here. So that makes it very easy from a compliance perspective for me to start building the case for, say, a potential audit, that here are all the different ways that I am complying with OWASP, right? And as Arthur was saying, there's 50 some odd sub items there. So it's important for me to know, okay, well, if an auditor cares about security misconfiguration, here are exactly all the checkers, A6, related to security misconfiguration, because it's not just one simple thing, it could be many. And this is really cool, right? Like when we filed for our CWE compatibility, there's all these questions like, how do people know which checkers are CWE checkers for which item? And when you're executing, how do they know what are all the violations for a checker? And when they find a violation, how do they know which CWE it belongs to? And when I'm doing a report, how do I know those same kinds of things? And what we've done here is just take all of that out of there. Normally, there's a whole bunch of manual effort at configuration time, at execution time, at remediation time, at triage time, at audit time. And we've just removed all of that. Our checkers are named for the items in the standard, whether it's CWE, CERT, OWASP, it's always native to the standard. Exactly. The next thing that is important here is, as the architect, there may be cases where I want to find out more about what the particular checker is doing, what its technical impact would be. So every checker comes with documentation where I can drill down into the specifics of it. Many of our rules or checkers come with parameters. So if you need to tweak it, as Arthur was saying, to be more appropriate for the context you're running it in, you can do that. There's also example code as well as example repair. So this is very useful for developers, which I'll get into next, is how does this all work from the developer's seat? And last but not least, every checker also comes with references. So if I'm curious, well, I know this checker is related to OWASP A5, but what does OWASP specifically have to say about it, right? I'm linked directly to that. And in fact, some of our checkers even have education training videos associated with them. So if I'm curious about exceptions and what the impacts of those are and what to do about them, there's additional information here in a video format as well, some training. And this is some really great training, because sometimes you're going to look at something like, well, why is exception handling a security issue, right? And so here it's going to talk about it. You'll understand the importance of it, and it'll give you some strategies. And part of this training, when you go through with it, there's not just video, there's actually like documentation and example codes and things like that. So we've done this in partnership with some of the people from the software assurance marketplace, Bart and Elisa. And this is some really good training that you don't have to pay for, which is amazing. A couple more things. One thing to point out is when Arthur was describing the workflow here, all these configurations that I'm choosing, maybe tweaking, these are all instantly shareable with the whole organization,
right? So this is the central interface that I, as the architect, can come in, decide, well, maybe I want to turn off severity 5 for now, because those are really the lowest impact things. We don't even want to look at them, right? Or whatever it is that I want to do, I can do that, and that's instantly available to the developers, the CI process, everybody that's interested. And speaking of sharing, all these rule docs are also exportable. So if there's a company wiki or SharePoint or something where we want an HTML page shared where people can go see it outside of the Parasoft infrastructure, that's available as well. But ultimately, as architect, it's really easy process. And, Parasoft has made it easy for me to go, I care about OWASP, here it is. I can tweak what I need to, I can research what I need to, but ultimately, this is now ready to go and we can start doing something about it. Let's secure our code. So with that, whenever I think about implementing a process and having, working on making the application more secure, my thoughts always first go to the developers themselves, because they're the people on the ground. They have to make the changes. They have to write better code. So I always like starting there. And when I think about, what do developers care about? There are a couple competing compulsions that we have going on here as it relates to coding standards or secure coding standards. And one, when I speak to developers, I often hear that they find the process frustrating. And this is code that they worked on in the past. They might not even remember this particular piece of code anymore. And they're fixing stuff instead of working on solving new problems, being creative, being challenged. Right? So it's something that they generally don't like to do. However, the other compulsion that I think balances that out is developers really take pride in their work, right? They don't want to be known as the person that's checking in insecure code or poor quality code. So, with all this in mind, it's really important that developers have the ability to be proactive, right? So when Arthur was describing the workflow, it's really important for me as the developer. Here I'm in Visual Studio. I need to be able to run the analysis locally on my desktop. We even have an option here where, much like spell check, it can run in the background. Anytime you save a class, it'll run a quick analysis and find things for me, even if I forget to do it before checking in.
And that's a really cool feature, right? There's some vendors out there claiming that they're the only ones that do this. So like you just saw, it's right here built in.
Yeah. We also, for Java developers, we do support Eclipse and IntelliJ as additional IDEs. This example, I've got .NET. But let's actually take a look at something here. So down here, I've got a violation for A1 injection. And we've got injection of data received from environment variable prop file name. So nice thing about .test here is it's actually highlighting the lines of code that are associated with this finding. And if we look at the finding details here, it's obvious to me that this particular checker is a flow analysis checker, because what flow analysis is doing is it's symbolically executing lines of code to try to find vulnerabilities. So it's looking for, if I take this particular path, am I going to find a security vulnerability? Is there going to be a hole? So if we take a note here in line 207, this is where we're reading in an environment variable. And a few more lines of execution down, you'll notice here, we are actually using that environment variable. So there's a potential injection of data coming in here, right? So this is identifying the path through the code where this vulnerability exists. And this is a great way of finding those gaps. When Arthur was talking about, what is the depth of your test case, right? Like how, there's some things we can find with flow analysis, some things we can't. There's another example I really want to show you here. It's a different checker, also related to A1 injection. However, this one's a little different. This is a preventative rule. And it's curious that we have two different checkers essentially flagging on the same line of code. This one, however, is recommending that you don't get environment variables outside of a validating method. Right? So here's a coding standard that's preventative, that's saying anytime you're reading in data externally that might be tainted, it might be dangerous, you should wrap that in a validation method.
And this is a really great strategy, right? Because when you're doing flow analysis, it's kind of like early cycle pen test in some sense, right? It's a little more white boxy, we have a little more knowledge, but we're poking at the thing, trying to break it. And the question is always, did I poke everywhere? The answer is, of course, no, right? Like you didn't. So did I leave some of these behind? And where if you implement this checker and you implement this style of coding, then you don't have to worry, did I catch them all? Because you did.
Yep, exactly. So also to point out, as a developer, when I see a particular finding, I also have access to the rule documentation for that checker. So everything I need is there available to me, integrated nicely with the IDEs, so I can quickly come in, find what I need to find, and fix it and move on with my life. Because ultimately, I just want to get back to working on interesting problems and getting challenged, right? Writing new code. So we take a lot of effort in trying to make this process seamless, quick and easy for a developer to come in, run the analysis, get it done, and move on. Now, there's one last thing from the developer's perspective at this point that I want to show you. And the conversation here is really about context, right? So we have a lot of checkers that are running. We're looking at a lot of different places in the code, and we're finding a lot of things. As Arthur was saying, some of them are bad smells. Some of them are strict, oh my God, you should fix this. Some of them are curiosities, right? Look at this, something seems wrong, and it ultimately the developer has to look and see what's going on with that code.
Yeah, the thing about security is the context is everything. Something that's dangerous in location A might be completely benign in location B. So one of the things, Wilhelm, that came up, there was a question about this in the chat box. And so I mentioned that we can do these suppressions or deviations both inline in the source as well as in a master database, as well as locally on the desktop. So you've got this up here and you can see all these different options there.
Yeah, we generally recommend to have the suppressions go in the source. This way, if you're branching the code or what have you, it's going wherever the code is. But we have some clients where they have strict rules around comments, and they really don't want to add any additional comments in the code, and so we have other options available. But ultimately, this feature is really the developer providing his or her additional context to what the checkers are doing. And this kind of leads me to the next part, kind of expanding on the notion of context.
And the cool thing here is that basically all these methods that Wilhelm showed you, they persist from build to build, from execution to execution, branch to branch, et cetera. There are some companies out there that talk about like trying to create a memory so that you can, remember things between things. That's not the terminology we use because it's just sort of inherent, right? The deviation or suppression or whatever you want to call it is inherently correlated with a specific piece of code. And that correlation is persistent.
Yep. So trust but verify, right? We want to make sure that the static analysis that we're running can be easily integrated into your build process, continuous integrations. So all our tools have a command line interface, integrations with Ant, Maven, Gradle, the various build systems that are out there. So once you have it integrated in your build process, oftentimes you also want to then gate the build for quality. So what that really means is, based on what the output is of our static analysis, right? If we really care about, being compliant with OWASP top 10, right? There's certain ways that these various standards can be broken down by severity, by likelihood, et cetera. So if that's something that you really want to drive towards and drive automation with, we have plugins with Azure DevOps. We have plugins with Jenkins and the popular CI systems out there where you can gate your build and say, we don't want to consider this build a valid build. We want to stop it if we see any Sev 1 violations for OWASP top 10.
And we can stick these links during the QA period. We'll just stuff them into the chat so people can click on them.
Sure, cool. So that's really all there is to show with regards to the trust but verify. I think the much more interesting area to get into is DTP itself. And so we have a number of dashboards kind of built in here based on the various different standards that you might be interested in. You'll notice here for OWASP, OWASP has that specific table about exploitability, weakness prevalence, et cetera. So we've actually implemented that to correlate to the results of the analysis. And so if I think this is the most important thing for me to look at, I can customize my dashboard how I want to show what I need. Right here in this graph, I might be interested in modifying this and saying, what, for this particular dashboard I want to build, I only want to see the severe impact violations, and it'll show that to me.
Wow, that number went down. So you got less work to do.
Yeah, so the DTP is highly configurable. It makes it really easy for me to take all the data that we're collecting from the quality practices like static analysis, unit testing, code coverage, et cetera, and making it easy for me to see what I care about and share it with the team. Now the third role that we've been talking about, right? We've covered the architect, we've covered the developer. This is a secure coding standards webinar. So we really want to talk about the security compliance officer, right? And this person's job is making sure that you're going to pass an audit. So let's talk about how DTP makes the compliance officer's job really easy when you're following these practices in your development process. So here I've got my OWASP compliance report. We have a very similar report for CWE or CERT or some of the other standards we've been talking about. In here, we've got a breakdown of whether or not we're compliant based on the various OWASP top 10 weaknesses. And oftentimes when we think about audits and auditors, they want to dig into the data. They really want to see, well, how are you compliant?
It's like getting your taxes together, right? When you're doing your taxes, gathering up all your receipts, et cetera. And what Wilhelm just did here, he clicked one button and just did everything. Mm-hmm. It's like he's been perfect bookkeeper all year long.
Yeah, so this PDF that we generated here is using the live data from the system and giving us that same overview we just looked at, and some other really important information, right? This is what your auditor is looking for. It's not enough to just say, oh yeah, OWASP A1 injection, we've got that covered. The auditor is going to want to know, well, how exactly are you getting that covered? If that auditor is competent, they're going to realize there's sub-items to injection. It's not just one thing, right? So you want to be able to prove, here are all the various different checkers related to injection that we're compliant with, right? So this is your weakness detection plan that is included with the compliance report.
And you have your build report as well?
Yeah, I can show that after.
There was a question around it, so after we're do that.
So the deviation report. So we were talking about the suppressions that developers can add in for as additional context, right? There might be some findings from the checker where the developer goes, you know what? This is a package that's internal into the application. There's no exposure from a user where this could possibly be a security issue. So, we're going to suppress it. All of that is documented here as well. So that's a really important part when you're thinking about this as a compliance framework, right? If there are exceptions to the rules, so to speak, those need to all be documented, right? Who did it, when, what was the reason? So that's all there as well. And then coming to the build audit report. So this is essentially your audit trail of all the different runs we did, what we found, which configurations were we running. So the data doesn't get lost.
Right, and this is in correlation with your CI system, right? So you can use this data here to couple to your CI system to show that, oh, I did this on that build, and that is this thing that I released, right? That I put into my final product.
Yeah. So, from a compliance perspective, DTP gives you the tools necessary to really make it easy to pass an audit when you're looking at secure coding standards. Now, there's one last area that we often get asked about, and I think is particularly cool. So, from this compliance report, say I was curious about these injection violations. Here we've got 77. If I click on it, this takes me to DTP's Violation Explorer. So oftentimes organizations will be interested in going through a manual prioritization or triage process of these findings, right? And we don't want them to necessarily have to set up a whole development environment on their computer and get everything plugged in. We want to make it nice and easy for them to review the findings in context of the code and have all the information necessary to go, you know what, this particular finding, I want to bump the priority of it, or I want to assign it to developer ABC so that they can start working on it. This violation history is particularly interesting to me because oftentimes organizations, they run the analysis, they find the findings, and then, oh, something more important comes up and they don't do anything, right? So if you're looking at this manual prioritization process, it's valuable to know, how long have we known about this issue, right? Did we just discover this, or has this been in the code for 2 years and we still haven't done anything about it? That might affect your decision. And this process here is tied to the developers that are working on the code as well, right? So if I jump back to the developer's perspective for a second, right? Developer can import these findings from the CI process, right? See, it went from 40-something to 408 findings now. So, essentially, when developer comes in the morning, they update their sources, right? They build the code in their IDE, and now they can import their static analysis findings for code that they wrote, right? We have the larger context coming from the CI process, so they can clean up anything that they may have accidentally put in into the source control from their last check-in.
And this is super interesting because sometimes CI results end up in a very webby format. And when I'm looking at reports, I like web format. But when I'm actually writing code, turns out I don't write code in my browser. Mm-hmm. I write code in Eclipse or IntelliJ or Visual Studio. And so the cool thing is here, we've taken the results of a CI build or an overnight build, imported them into my desktop IDE, and they look to me just like the ones I ran locally. I literally can't tell the difference. So I can click on something, it takes me file name, line number, right to that violation. I've got the docs there, I've got the suppress, I've got all the things as if I'd run it locally. And this is important, again, because you're trying to catch that bigger context. Maybe it's not just my code now, it's my code integrated with your code, and I found a violation on the boundary, Or it might be that my code plus your code plus everyone else's code takes 3 hours to scan because it's 25 million lines of code. And so I don't want to wait for that because, you know, it's a little long for a coffee cup. But I still get that same experience. I don't have to come to a web page, look for something, cut and paste the file name, go find the file, etc. Right? It's just like, it's very easy to work here.
Yeah. So, you know, that pretty much wraps up all the different topics that we're gonna go over today.
So yeah, there's a couple of things that you should have in your when you're looking at tools for the standard, and I just thought I'd include this as a bonus here at the end. One is, you know, make sure that the static analysis tool you have can run from your IDE, right? Because again, that's where you need the results. So critical function, make sure that it has support to run on your build servers and CI systems, right? If you have something that just won't work in your world because you're pushing stuff out into AWS or whatever it is, then you're not really going to run it as often as you should. So make sure you can consume it. One of the things we have a bunch of integrations that you saw from Wilhelm, but we actually have a CLI because, like, at the end of the day, you can always integrate it with anything. Make sure you have centralized configuration control. You know, it's one thing. If you've got 3 or 4 people, it's easy to go, hey, I made the config here, Wilhelm, Bob, and Sue, you can all get the same config. But once I've got multiple teams, multiple divisions, multiple groups, I've got 1,000 engineers, how long would it take me even to push something? And the answer is we don't push it, right? It's in central. And when I change the config as architect and Wilhelm goes to run his static analysis, it automatically pulls and checks for the latest and does what it's supposed to do. So I never worry that somehow Wilhelm is doing something different than what I want him to do. So very important. Again, centralized reporting, audit, analytics. If you're just trying to do some random security, then sure, you can live without this. But if you're actually trying to secure your software and get ready for compliance, whether it's PCI or FDA or whatever it is, HIPAA, then you need to make sure that everybody's doing the same thing and that your reports reflect that so that you don't have that, okay, at the last week of the quarter, we all sit down and gather reports up and then by hand put them together. And I know that a whole bunch of you out there going, oh man, that's me. So like, if that's you, don't feel weird. Like lots of people do that, but you don't have to. Make sure you have a full range of checkers. By full range, I mean 2 things. One is make sure that you cover the entire standard, right? That there is a checker for every item in the standard. Otherwise, the auditor is going to say, hey, how did you do A7 in OWASP? And you're going to say, oh, I didn't. Now you got to do peer review on that thing. So make sure that it covers everything in the standard, but also make sure that your static analysis tool has, you need flow analysis. You need to make sure that you can look for tainted data and things like that. But you also need things that look for code smells, that look for problems that are contextual. And you need things that implement preventative rules, because at some point you're going to get tired of chasing and plugging injection holes. And the only way to get ahead of that is preventative checkers. So if you're running a tool that's flow analysis only, it simply can't be as thorough as you need it to be in a compliance environment. And yeah, okay, so I basically said that there. So with that, we're going to take some Q&A. Now, we've been taking Q&A all along in the chat box there. And there's also a QA box, so feel free to type it in there as well, and we can handle it. We have a few things that I'd like to handle. One that came in was, I'm already following MISRA, so do I still need to do something extra for security? Now, from a compliance perspective, probably not, because MISRA is what you need to do. But is your code secure? Probably not, right? MISRA has this security addendum, so it's better than it used to be, but I would suggest if you're doing MISRA for automotive or medical devices or something, I'd presume it's like functional safety, I would look at doing CERT or OWASP or CWE, maybe UL 2900, to enhance your functional safety. Now, you'll find that a bunch of what you did for MISRA fixed issues that would have been security issues, because like buffer overflow is a performance and reliability and safety issue, but it's also a security issue. So it won't be as bad as you think, but you do need to do more. Okay, so we have another, let me just check the Q&A box here. We have another, which is, I've tried static analysis before, but the noise and the false positives were enormous. How do I handle so many violations? So yeah, that's one of the problems. Part of the problem here is that some of the checkers require context, and that context ends up having to either be a human or a full application or something. It might be that there's a little piece here that does some funny logging that normally would be an illegal log, but in this case, it's captured by some other interceptor, and the static analysis tool doesn't recognize that interceptor. So there are things that you're going to have to do by hand. But what we've done here to make it easier for you is giving you ways to have more than just severity, right? Like, okay, let me fix only critical things. Well, that's still too many, right? So now I can say, well, let me fix critical things that are easy to fix. I'm going to start there, right? I want to give my manager a big win. I fixed 500 violations today, right? Like things that are easy to fix and have a big impact, and the impact is critical, like that's where you start. So that's why we implemented all these risk models to help you quickly trim. You saw when Wilhelm changed from all to what it was to severe, that it went from like 1,500 to 500 or something like that. So right away he cut his work in third. And then on top of that, we have implemented further sorting and manual triage. And DTP, you can actually even apply more analytics if you want. If you got a special thing in your workflow that you know that everything coming from this component is considered safe, we can configure it for you so that that component is configured safe. So there's a lot of different ways you can do it. But yeah, like that is the reason why people get frustrated, right? It's absolutely the reason why people get frustrated. All right, what else have we got here? We got a couple more minutes. I've never heard of CWE cusp before. Is it important? So if you're just starting out, I'd say no, start with the top 25, right? But if you're at that level where, hey, we've been doing the top 25 for a few years, we're comfortable with it, we're pretty clean against it, like, how do we take our security to the next level? Because obviously anything that says top in the list isn't comprehensive, right? So I would say cusp is a really great next step. Or if you're going to do like medical devices, FDA and UL 2900 are really a match made in heaven. So I would say in those cases, it's a pretty good idea. Let's see. We're pretty good with the OWASP top 10. What's a good next step? There's a great question, right? Because people who have been concerned with security for a couple of years generally started with OWASP, especially in a web application. I would go from that next step. I would probably go add in like CWE top 25, just because now I'm going to branch from 10 items to 25 items, and that's probably your good next step. There's a question about, should I run static in my IDE or part of my CI? Again, you know, Wilhelm and I are both trust but verify guys. I believe the developer should be running it in the IDE, and that's primarily where you should be finding violations. And the CI should be primarily verifying that there are no violations. If your CI is finding lots of things and having to go back and fix them, you either have a bad configuration or you probably want to go start looking at a preventative rule, because that verify stage should be verify, not detect. And that's a better strategy to be there. And one final one, is there a language that's more secure than others? That's a great question. If you ask government people, they'll all say Ada, right? But every language has its own unique consequences. That's why CERT created a different standard for each language because of the specifics. In general, the principles apply, but yeah, each one has its own unique challenges, and I don't know that I could recommend one language over the other for you. Use the language that's right for your job, but I would say avoid languages that don't have good, rich tool sets. And the truth is that languages like Python are great for prototyping, but they're actually not good for analysis. And so it's very hard to actually prove that a Python program is fully secure, for example. So just something to keep in mind. And we thank you all. And if you've got suggestions, if you'd like to learn more about a particular standard, et cetera, let us know. Wilhelm and I are happy to dive deep and do a whole hour on any particular standard you want. So thanks again, everybody, and have a great day.